And here we are on the final video for section 3.3, and we're going to be looking mostly at what is called the rate of change. Now, this does not require a graphing calculator. It just requires a lot of algebraic skills. That's what we have going on here. Now, the average rate of change, the formula looks something like this: f of x sub 2 minus f of x sub 1 all over x sub 2 minus x sub 1. That's what the formula says. But realize that it's basically finding the average is what it amounts to. So suppose we have f of x equals 7x cubed plus 7x squared minus 2. And we want to go from -9 to 4. So the first thing we're going to do is we're going to plug in f of -9. f of -9 is 7 times -9 cubed plus 7 times -9 squared minus 2. And when we figure all this up, it ends up equaling -4,538. I will leave it to you to come up with that particular value. Then we need f of the other boundary, f of 4. And so that would be 7 times 4 cubed plus 7 times 4 squared minus 2. And once again, leaving it up to you, you would soon realize that f of 4 is 558. Now, how we put this in, we take the second value, 558, minus the first value, -4,538, divided by the first x value minus the second x value, which is -9. And then after doing all of the appropriate calculations, we get 5,096 over 13, which equals 392. And so what is the average rate of change? The answer is 392. Okay, example number 15 is exactly the same, just different problems. So we get f of x equals -3x squared minus x, and we're going from 5 to 6. So the first thing we need to do is find what is f of 5. Well, that's -3 times 5 squared minus 5, which will equal -80 when it's all said and done. f of 6 is -3 times 6 squared minus 6, and that equals -114. So then putting it into the average rate of change, it's -114 minus a -80 all over 6 minus 5. And doing some quick calculations, we get -34 over 1, which equals -34. And so the average rate of change would be -34. Example number 16 is really no different. It just says we want the average rate of change from 1 to x. And they give us a new formula, but it's exactly the same thing. So we have f of x is equal to 5 over x plus 4, and we're going from 1 to x. So what does that mean? Well, we plug in the first one, f of 1. f of 1 is 5 over 1 plus 4, which, when it's all said and done, equals 1, because 5 over 5 equals 1. And so what we need is, we need the second one. Well, f of x is 5 over x plus 4 minus f of 1, which is 1, all over x minus 1. And then it's just algebra from this point forward. So getting the common denominator up here, that would be x plus 4. So 5 over x plus 4 minus x plus 4 over x plus 4 all over x minus 1. And let's see, combining this into one big fraction up here, we get x plus 4 in the denominator, and this would become 1 minus x all over x minus 1, as shown here. Now, this 1 minus x is very similar to x minus 1, except we do need to do one small thing to convert it so that we can actually do some simplifying. That's the opposite of x minus 1. And so we get that all over x minus 1, and all of a sudden the x minus 1's cancel each other out, which will leave negative 1 over x plus 4. And so the question now becomes, can this go any further, or is this in as simple a form as we can go? And the answer is we are done. So what is the average rate of change from 1 to x? It's negative 1 over x plus 4. And once again, this is number 16. And then the final problem, problem number 17. Number 17, we are asked to find the difference quotient. The difference quotient is given right there in the homework. It's f of x plus h minus f of x all over h. So the first thing we're going to have to do is we're going to have to find, well, we know that f of x, at least according to number 17, is 4. So that's pretty simple. But then what we need to do is we need to find what is f of x plus h. And realize that this simply means wherever we see an x here, we have to put in x plus h. Well, that's pretty simple. It's 4 in this case. Now, if this were 4x, we'd have to do 4x. In fact, I'm going to change it just slightly because this is really it doesn't really fit. So here it's going to be 4x. I'm changing the problem just slightly. And then this would become 4x plus h. So now the difference quotient, according to the directions, is f of x plus h. Well, of course, this equals, well, we don't want to carry that out. Do not carry that out, at least not right now. So it will be 4 times x plus h minus 4x all over h. Now let's see what happens here. I'm going to have to distribute this. So this becomes 4x plus 4h minus 4x all over h. Notice the 4x minus the 4x cancel each other out, and so we're left with 4h over h, and the h's can cancel, which leaves the value of 4. Now realize, knowing calculus, this 4 was very easy. I mean, I could have looked at the 4x and said 4 is the answer. But if we go back to the original equation as shown, and that is 4, let's quickly do that one. This was my revised one. But now let's look at the one that's actually given. And I'll show you how much more boring that is. F of x was 4. F of x plus h was also 4 because we get the same thing. So then putting the values in, f of x plus h minus f of x all over h. 4 minus 4 is 0 over h, which equals 0. Once again, knowing calculus, I could look at that and say, yes, the difference quotient is 0. Just like the difference quotient here, I can look at this and say that answer is 4. But realize you need to really get into calculus before you know that nice little tidbit of information.